Guess that you're all fine. So in this video, I'm going just to show you my project in data science, or it consists to show to choose a problem in our own and resolve it. So in down here is the follow question that we have. We have to scroll down. We have in one, we have to define, to choose our problem. In two, we have to define the objective and questions. And at level 3, we have to justify our data set that we have downloaded. And in 4, we have describe data in terms of types. I talk about qualitative, quantitative, nominal, ordinal, continuous, and discrete data. So without wasting our time, we are going to begin. Firstly, about the problem that I've chosen is a financial fraud detection. Financial fraud detection here I've downloaded is a problem in cybersecurity which allows us to detect a fraud in a financial transaction and so on. So in this problem, they are focused on the financial fraud detection in mobile money. So the objective and question that we have defined in our video are here. Firstly, our main objective is to predicting the detection fraud in mobile money transaction. And the question here are so on. And firstly, we have what types of transaction appear in the data set and what are their frequency. So we are going to check a frequency and also to learn more about the data set. And in two, we have what type of transaction are most susceptible to fraud. Thirdly is what is the distribution of amount in fraudulent and non-fraudulent transaction. In fourth, are there any balance characteristic associated with fraud? And at last is how a fraudulent transaction distributed over time. So in this case, we are going just to explain the step. And in three is acquire data set and justify sources. About our data set, I have downloaded in the Kaggle. Kaggle is a reputable platform for data science, and this data set was generated using a simulator called simulator tools who is PaySim. So we can download this platform, this data set on this link in the below. So in fourth is a description data in terms of type and so on. So we have in our data set we have a step who is the first variable in our data set, and we're going just to give the quantitative variable of this variable. So the type of this variable is a quantitative variable, and the description of type is a categorical nominal variable. And amount, the variable amount is a continuous quantitative variable. And name ORIC is when customer who started the transaction is a nominal quantitative variable, and all balance org initial balance before the transaction is a continuous quantitative variable. News balance URIC is a continuous quantitative variable. Name des is a nominal quantitative variable. And alt balance des is a continuous quantitative variable. And new balance des here is the continuous quantitative variable too. And is fraud is a categorical variable. And at the last we have is a flag fraud is to the categorical variable. So we have to realize in 5 question the EDA. EDA is exploratory data analysis. So firstly we have mount our project on Drive, because our data set is uploaded on Drive. And after that we have if I use import this library pandas as PD. Pandas is a library that can allow us to manipulate and analyze the data frame, and also the data frame in many format like CSV, JSON, Excel, and so on. And the NumPy library here is allow us to manipulate the data frame who have a multi-dimension. And we have a matplotlib. Matplotlib here is a library it can allow us to make a diagram and so on, diagram, and also data visualization and so on. And a Seaborn as SNS. Seaborn here is a library who allow us also to make visualization of data, and also data in statistics and so on. So before starting about our reading our data set, we define our data set like this: data equal PD point read and so on. So this code allow us to read our data set. And here is the basic information about the data set. Our data set here is the tail, is the weight of our data set, is a line, and here is the column. And this comment, this code allow us to get out the first line of our data set in default, but you can take some value in the parameters. So here have choose 7. It means that if we execute this code, it can get in out the 7 first line of our data set. So let's continue. And we have also data point info. Data point info it can allow us to have a type of all our variable in our data set. So like step is int is integer, and type is object, amount is a float, and so on. And the data point describe here give us the mean, the description on our data set, and he compute us the mean, the STD, standard deviation, and give us the minimum and the maximum and so on. And data point is NA. This code allow us to know if we have a missing value in our data set. And we notice here that we have not a missing value in our data set, because all these variable have a zero like a missing value. And about the distribution of transaction types, here is a distribution of transaction type. We have used a count block. Count block here is a type of library of scene bin, will allow us to see the distribution of transaction type. Here is in function of account, variable, and transaction type. So let's follow. And here we talk about the distribution of amount variable. So it's a figure of the distribution of amount variable. And analyzing fraudulent transaction. In this case, we try to get in output a diagram of the fraudulent transaction in function of account and non-fraudulent transaction. So if we have 0, it means that it's non-fraudulent, and 1 is fraudulent. Let's continue. We have used a box plot for amount by transaction type. So in this case, we use box plot. Box plot allows us to have outlier value, and also a main value, and also a quantile value. So we notice that at the higher begin from 10 expose 5 are the outlier value, you know. And this diag is box plot are created by in function of amount, variable, and transaction type. And here we have a correlation analysis. So in correlation analysis, this correlation analysis allows us to understand better the relation between two variables. So if we chose, by example, alt, if we chose all balance ORIC and new balance ORIC, this cellule have one like a symmetric value. So it means that the correlation is higher. If the correlation is higher, it does mean we can just from one value, from one variable, we can have information about the another one variable. Here we talk about hold balance and new balance analysis. Here we use scatter plots, will allow us to make data visualization about a continuous variable. So here is a continuous variables between new balance origin and all balance origin. So we notice that if we have 0, the blue one is the fraud, and the green, the yellow, sorry, the green is the non fraud. So it is just a tendency, the tendency of our variable, our continuous variables. Here we talk about all balance and new balance for destination. So in this case, we try to make a same thing. we use the library, the same type of data of a graphical with a scatter plot. So it's here it allows us to have to know exactly the fraud, the data fraud detection and non data fraud detection. So we notice here that here is a fraud detection, the data fraud detection, and when we have a 0 here is they have a same color, so is a non detection in our financial data set. And we have to analyze about our variable who is flake fraud. Is flake fraud here? We have traced this graphical by focus on one variable who is an account. So is flake fraud have two parameters: 0 for say not flake and 1 to say flake 2. And we have in our sixth question, it's asking to build graph that show distribution missing values and outlier. So we have three functions here which can allow us to have a distribution and missing values and outlier. So if you want to have a distribution, this code plot underscore distribution who have in parameter our data show us a distribution of each variable. So here is for distribution of amount, distribution of all balance org, and distribution of a new balance org. And after this we are going just to execute our another code to see a missing value in our data set, or we have to write plot underscore missing underscore value who have in parameters our data. So this missing value, you notice here that there is no missing value in our data set because there is nothing in our graphical type. So at the last we are going to see outlier value in our data set. So plot underscore outlier who have in parameters a data allow us to have outlier value. So those things here, those graphical here show outlier value in the black, the black graph here. So we check also in each value in our data set, we check outlier value. So here is a graphical of our outlier value in our data set in general. So here is for amount and all balance and outlier in all the balance here. So thank you so much for being kind about this video. Let's see what I'll say in the next time. Thank you.